This is the video notes for 9.7, Bridging the Gap. This is a Solidify Understanding lesson, and starts off by saying your job in this task is to figure out what the standard deviation measures are and how to get a sense of how changes in data affect standard deviation. Okay, so this is all about standard deviation. Okay. Your teacher will give you a set of strips that each contain a set of data and a dot plot that represents the data. Follow the instructions for each problem below and be prepared to discuss your findings. All right, so we are going to look at the data strips. So here they are. There are 7 sets of data strips. Okay. So here's our first set right here. And what we need to do first, number 1 says, use technology to find the standard deviation for each set of data on the strips you have been given. And the technology that we're going to use is the Desmos graphing calculator. And I'm going to go back to the notes. So here are our notes, right? And I'm going to, in this white space up to the right, I'm going to make a list of how to use the Desmos graphing calculator to find the standard deviation. Okay, so let's do that right here. To find standard deviation using Desmos. Okay, so our first step is to open a new Desmos graphing calculator, and we're going to add a table. So add table. To add a table, you click on that plus sign, upper left, right? And we are only going to fill in the X values. So fill in X1. Okay. And the reason we're only filling in the X values is because this learning cycle we are studying single variable data. So we only have X values. Okay. Once we've added a table and filled in the X values from our data set, then the next step is going to be to use I think it's called functions. Let me look really fast. Yeah, so we're going to use the functions menu in Desmos. Use functions menu. And the function that we're looking for is called standard deviation P. So we're going to click on STDEVP. So that's the one we're looking for. Do not choose the one that is missing the P. The P stands for population. So we want to find the standard deviation of the whole data set, the whole population. So this is the one we want to use, okay? So this is very important that you select the right function from the functions menu. All right, so now that we have our way of using technology to find the standard deviation, let's go and do it. Okay, so we're going to be working on number 1 right here. Use technology to find the standard deviation for each set of data on the strips you've been given. Okay, so this is the first strip that we've been given, right? It has the data set 1, 1, 1, 1, 1, 1, 10, 10, 10, 10, 10. So we're going to transfer that data over to a table in Desmos. So here is our Desmos document, right? And we're going to do the plus sign and hit table, and we're only filling in the X values. So the X values that we want are from set 1, and we're going to go 1, 1, 1, 1, 1. I need to hit enter in between, my bad. 1, enter, 1, enter, 1, enter. So that's 3, 4. I need one more. Okay, 1, 2, 3, 4, 5. Good. And then I'm going to have 5 tens. So 10, 10, 10, 10, 10. And then I go here on the right, you see where it says functions. And I'm going to click on it, and I'm going to go to the stats, and you see all these statistical functions that we could do. We're going to go to the middle column, third one down, where it says standard deviation, STDEVP. That's the one that we're after. And we're going to put that in the next line. So after our table, we're going to click on the next line, 2, and we're going to hit standard deviation P. And now we need to tell it, okay, where's the data set that we're going to use? Well, it's this data set in this table. It's all those X1 values. So I'm going to type in X1 to find my standard deviation of that data set. So it is 4.5. So I'm going to switch over now to our notes. And our standard deviation is 4.5. Okay. And I'm going to record them all here first, and then I'll record them on our lesson notes. So I'm going to record them on the strips first. Okay, here's our next data set. So I'm going to do the same thing. I'm going to transfer all of this data to our table, just to the X values. So we'll go here, and I can use the table that I've created, right? I don't need to make a new one. So I'm just going to delete what's there. And you do my second test strip. Sorry, second strip of data. And it starts with 5. How many 5s are there? 1, 2, 3, 4, 5. So 5, enter, 5, enter, 5, enter, 5, enter. And then it goes 4, enter, 4, enter, 4, enter. And then there's 3 6s. And then 2 3s. And then 2 7s. All right. So here we have our standard deviation. It is 1.25. So let's go and record that. Second strip. So 0.25. Okay. So we've done set 1 and set 2 now. Let's move on to set 3. So for set 3, we'll go back to Desmos and we'll do the same thing. We will delete our X values and put our next one. Okay, I think I need to open Desmos again because I zoomed in too far. Okay, this is our third data set right there. So add our table, and then I'm going to type in 1, enter, 2, enter, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 9, 10. And then I'll use the function standard deviation P, and then I'll have it reference X1. So my third standard deviation is 2.87. Okay, so let's go record that over here. 0.87. Okay, and then you would just continue doing this for all the other strips. So you would do this for set 4, but I'm just going to jump ahead since I know the standard deviation for 4 is 1.64. 1.64, since I've done this already. And then for set 5, I would also put the data into Desmos, and I would get the standard deviation of 0.5. Okay, and then for set 6, I would get a standard deviation of 3.15. Okay, 3.15. And then for set 7, this is our last set, I would take it to Desmos and I would get a standard deviation of also 3.15. I think I have a mistype in my book. Let me look really fast at that. So I think that 6 and 7 have the same standard deviation, but I want to verify. So it looks like yes, they both have 3.15. Okay, 3.15. Okay, looks good. So now we're going to go ahead and record that in our notes. So back to our notes over here. And I'm going to use some notation, a Greek symbol for the standard deviation. It's just the Greek symbol that is always used for the standard deviation. Okay, so we use sigma for standard deviation. So I'm actually going to just write a note up here that we use Greek letter sigma for the standard deviation. And the way that you write sigma is it's a kind of a circle, and then it has kind of a tail on top like this. Okay, so that's the Greek letter that we use for standard deviation. Sigma. All right, let's go ahead and record all our standard deviations for part A. So here we have set 1 sigma equals 4.5, set 2 sigma equals 1.25, set 3 sigma equals 2.87, set 4 sigma standard deviation is 1.64, set 5 sigma equals 0.5, and then set 6 sigma equals 3.15, and it was the same thing for set 7. Sigma standard deviation was 3.15. Okay, so those are all our standard deviations. Arrange the strips with the standard deviation from least to greatest. Write the sets they represent, describing the patterns or trends that you notice. Okay, so least to greatest, it would be set least to greatest. It would be set 5, then set 2, then set 4, then set 3, then 6 and 7 are the same number, right? And then 1. Now, what trends are we noticing? Why does it go 5, 2, 4, 3, 6, 7, and 1? So let's look back at the strips. So why does 5 have the least standard deviation? Do you see how grouped the data set is? Right here, look how grouped that is. They're so close together. There's not a lot of spread, right? Standard deviation is a measure of spread. So that makes sense. That would be the least. 2 is the next. 2 has some spread, right? Look at that. That's a very, we've seen that shape before, right? That was in the previous lesson. That is a symmetric shape right there. So that's a little bit more spread out. Number 4 is the next one. Okay, so that has more spread than number 2. Okay, that's even more spread out. Okay, the next one is number 3. That is quite spread out. It's covering like the whole number line, but there's a data point on every number. Okay, the next one was 5. Was it 5? No. Next one was 6 and 7. So 6 and 7, oh, it looks so similar. Look at those. This 6 is skewed right. Do you see how we have this huge amount of data here and then almost like an outlier to the right? So that's going to have a big spread, big standard deviation. Same thing here. 7 is skewed left. There's the majority of the data and then our outlier. And then number 1 had the greatest standard deviation. Yeah, look at that. This has kind of an even amount of data on both sides, but really far apart. Okay, so that makes sense as far as like patterns that we're noticing or trends. Okay, let's move on to recording those trends. So this over here, least to greatest, this is very grouped. And I'm going to say this is very spread out. Very spread out. Okay. All right, number 2. Compare data sets 4 and 2. Which one has the greater standard deviation? Why do you think the standard deviation is greater for this data set? Okay, so we know that 4 and 2. So we're looking at these two, 4 and 2. So 4 has the greater standard deviation. So set 4 has greater, and I'm just going to write SD for standard deviation so I don't have to write it out. And let's see why. I want to actually go look at 4 and 2 to determine why. So here is 2. Let's try to get 4 and 2 on the same page. I'm going to zoom out. Here's 4 and 2. So 4 has the greater standard deviation. I think it's because it has a gap in the data in the middle there. And kind of, what's that shape called? So I said 2 was symmetric. I feel like 4 is more kind of like bimodal, right? It's got really high amount of data on the edges, but in the middle it goes down and there's no data at 5. Okay, so that makes sense that this would have a higher standard deviation because of that gap in the middle. That's what I'm thinking. And the data is farther from the center. Absolutely. Okay, so let's add that in to our answer for number 2. Set 4 has a greater standard deviation because more of the data is farther from the center of the graph, is farther from the center of the graph. All right, number 3, look at data set 6. Okay, so we're going to focus on 6 next. What impact did the 10 have on the standard deviation? Okay, so let's look at data set 6. Here it is. Yeah, that 10 is really far away. That's going to make the standard deviation, the spread of the data, right, bigger. It's kind of, I talked earlier about it's kind of acting as an outlier, right? So let's kind of list a few things about that set. So, okay, the 10 made the standard deviation bigger, okay, or greater. That's definitely true. If we eliminated it, all the data points would be on, let's look back again, all the data points would be on the 1, which if you have all the data points on the same number, you actually have a standard deviation of 0. So that would be a big impact if we eliminated it. If 10 was eliminated, the standard deviation would be 0. Oh, I forgot to put the F on if. And then one more observation. If 10 were a bigger number, so let's say it was like 15 or 20, that would increase the standard deviation. The standard deviation would increase. Okay, let's go ahead and turn the page. Let's look at number 4. Number 4 says, compare data sets 6 and 7. What do you notice about the standard deviations for these data sets? Why do you think this is the case? Yeah. Okay, so just looking up here, right, the standard deviations are the same. They're both 3.15. So we can say the standard deviations are the same. And the reason why is because the data points are spread exactly the same distance apart. They're just kind of the mirror image, right? Because the data points exactly if we want to go back and look at those two, right, these was 6 and 7. 6 had 6 dots on 1 and 1 dot on 10, and then 7 was just reversed, 6 dots on 10, 1 dot on 1. All right, let's go ahead and do the next one. Okay, number 5. Create your own set of data that has exactly the same standard deviation as set 2, but a different mean. Okay, now remember, the mean is the average. It's a measure of center. So a quick way of adjusting a data set and keeping the same standard deviation but changing the mean is just adding one number to each of the values in data set 2. So I'm going to do that. So data set 2. So new data set 2. Instead of going 5, 5, 5, 5, I'm going to go 6. Just one additional number, 6, 6, 6, 6. And then 5, 5, 5, 5, 5, 5. And then 7, 7, 7. So I'm just adding one number to each of the data set in set 2, then 4, 4, and then 8, 8. Now, if we put this into Desmos, we would see that our standard deviation is still 1.3, right? Let's verify that's set 2. Set 2 right here. Yeah, 1.25, 1.3. But our mean is shifted to the right. So let's look back at here. Let's see what the mean is for this data set. So here's our mean right here. Our mean is the average, the mean would be, you would add them all up and divide by how many they are. I'm pretty sure you would get 5. Let me do that really quick. So we would go 3 plus 3 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 5 plus 6 plus 6 plus 6 plus 7 plus 7 equals, and then you divide by how many there are. Yeah, so the mean was 5 originally. And if we shift all the data set points 1 to the right, we end up with a different mean. Our mean ends up being, instead of 5, it's 6. All right, what does the standard deviation help describe in a distribution? It describes the spread of the distribution. Sorry, I missed the T on the it. It describes the spread of the distribution away from the mean. So how far away are the data points from the mean? And that's like in both directions. It's describing the spread from the mean. All right, let's do number 7. Samantha is entering a bridge building contest for her math class. The winner of the contest will be the student who can build the bridge that holds the most weight. As she is getting ready to build her bridge, she has narrowed down his decision to 3 different designs that she could use. She has data from bridges that have used the 3 different designs from previous years and is trying to decide which design to go with. The data for the amount of weight in pounds for the 3 different types of designs are given below. Which bridge design should she use? Use both graphs and numerical summaries to back up your decisions for the best design. All right. So I'm going to go ahead and go to Desmos, and we're going to put in our data for design 1. So we're going to kind of split this zone down here into 3. So this will be for design 1, that's design 2, and design 3. Like that. Okay. So design number 1, design number 2, and then design number 3. Okay. So, and what we want from Desmos is the mean, right? The average for each of the designs, and we want the standard deviation, and then we'll talk about our findings, right? So we're going to find the mean and the standard deviation, the mean and the standard deviation, the mean and the standard deviation. Okay. All right, let's do design 1 first. Okay, so we're back in Desmos. I'm going to clear out this table. Actually, a quick way of clearing it out is deleting it and then adding a new table. And then here are the values for design 1. 850 pounds, 912 pounds, 980, 1012, 1060, 1407, 1600, 1602, 1680, and 1700. Okay, and these are all pounds. So now we're going to go to functions. We're actually going to use 2 functions this time. We're going to do the mean. We're going to use that table, right? So the values are in the x1. So that's our mean. And then we're going to do another function. So function and standard deviation p, right? That's the one that we want right there. x1. All right, so we've got our answers. So our mean, our average is 1,280 pounds, and our standard deviation is 330. And I'm just going to round to the whole number for all of these. So 1,280 and 330 pounds for the standard deviation. Now, what I would do is go back to the Desmos graphing calculator and put in the data for design 2 and 3, but I've already done that. So let's just record right here. So the average, the mean for design 2 is 1446, and the standard deviation was 42 pounds, very small standard deviation. And design 3, the mean was very low, 1,003 pounds, but the standard deviation was 409 pounds. So now we're going to go through and kind of talk about each one, what we're seeing. So for design 1, potentially this could be the winner right here. Because let's say, so it has a standard deviation of 330, so potentially it can go up to 1280 plus 330, so that's what, 1610? So that would be more than the mean of design 2 and design 3. So potentially, like, this can hold more weight than the other two. Potentially can hold more weight than number 2 or 3. But you have to be careful because the standard deviation is not just the mean plus 330, it's also the mean minus 330. So potentially design 1 could be as low as 950, right? Which is like really low. So I'm on the fence about this one, right? Okay, design 2, I really like the mean of the average is really high, and it has a very small standard deviation. So this standard deviation means that it can, design 2 can go as low as 1404, right? Or as high as 1488. So this one is actually really safe. I like design 2 a lot. So I'm going to call this our safe option. Okay, because we're guaranteed to hold a lot of weight with very little deviation below the average or above, right? Only 42 pounds. So it's safe option, holds a lot of weight, holds a lot of weight. And because it has a very small spread, that's why it's the safe option. Very small spread. Okay, let's look at design 3. I really do not like design 3. Look at that. This average is a 1,003, which is lower than the average of the other two. And it has a huge standard deviation, meaning like the bridge using this design could be as low as only holding 600 pounds or as high as 1,400 pounds. So I really don't like design 3. So this has the lowest mean, but I don't know if you look at design 3, look at this outlier right here. It has the potential to hold so much more than anything else. But had a bridge that held 2,257 pounds. And I kind of feel like that's unusual, so I'm going to steer away from design 3. I think I'm just going to go with the safe option, and I'm going to go with design 2. Because that one I'm guaranteed to get in the 1400s for my bridge. All right, let's go ahead and do our takeaways. In our takeaways, we're going to list a few things that we learned about standard deviation. First, let's just define it, right? The standard deviation is a number used to tell how how the data is spread out from the mean. Okay, so it's a pretty useful measure of spread. Let's look at some facts about standard deviations. So if you have a greater standard deviation, what does that mean? The data is very spread out from the mean. The data is very spread out from the mean. Let's see if we have a smaller standard deviation, then it tells us the data is clustered around the mean. And what if we have a standard deviation of 0? What does that mean? It means all the data is at the mean, right? If we think about a dot plot with a standard deviation of 0, all the dots are lined up above one number. All right, let's fill out our next part, standard deviation and mean. Okay, so standard deviation is a measure of the average spread. Is a measure of the average spread from the center. So it's always measuring like how far away from the center from the mean. Okay, what else? If data points are the same, we just talked about that above, up here, right? Right there. If all the data points are the same, then the standard deviation is 0. Okay, let's do our next one. Okay. Oh, interesting. Okay, so the standard deviation is a non-resistant. I just had to look up what non-resistant meant, and I'll tell you what it is in a moment. Measure of spread. So what the non-resistant means right here is that it is heavily influenced by outliers. So I'm going to write that right here. Heavily influenced by outliers. Okay. So it's not just the standard deviation that's non-resistant, it's also means. So means are non-resistant measures of center. So means are also heavily influenced by outliers. Okay, and then something else that's important about standard deviation is mean is don't forget to always connect these two ideas to the context. Think about what standard deviation and mean represent in context, like in this story, right? Like in the last task we did was the bridges and how much weight they were holding. So it's important to always think about what these two numbers mean, what they represent in context. All right, so that is our lesson 9.7, bridging the gap. In this lesson, we learned about standard deviation, which is a measure of spread for single variable data. The standard deviation is 0 when all the data have the same value. That's something that we learned. All right, I hope that this video is helpful, and I wish you best luck on your practice.